Okay, so looking at our notes, our first vocab word here is scale drawing, and it says a scale drawing is a drawing that is reduced or enlarged by a certain number on all sides without becoming distorted. So we have a couple key words there. Certain number on all sides is important, and then we don't want it to become distorted. So if I look at these two images, if I look at these first, I have this square and it has become enlarged. And you can tell that the side on the left and the side on the top have both been enlarged by the same amount because it's still a square. The shape has not changed, the angles have not changed. Okay, now if we look at this one, we start out with a little square and they enlarge it. So it is bigger, but now it's become distorted. It is no longer a square. So it looks like they made this side, let's say maybe 2 times bigger, and this side maybe 4 times bigger. So they did not make both sides bigger by the same amount. So it went from a square to a rectangle. So I'm going to put a check mark next to this one because this is scaled correctly, and I'm going to put an X next to this one because it was not scaled correctly. It completely changed the shape. Okay, so when we're talking about scaled figures in math, we're going to be paying attention to the side lengths. So we're going to try to figure out if the second shape is a scaled copy of the first shape. And we can do that by seeing if we make the one side and the longer side both bigger by the same scale factor or scale number. So to go from 2 to 4, I multiply by 2. And to go from 3 to 6, I also multiply by 2. So since I multiplied both sides by the same number, it is a scaled copy. Looking at our triangles, to go from 9 to 3, I divide this side to this side, I divide by 3. And then the two bottoms, the two bases, to go from 9 to 3, I again divide by 3. So I divided both sides by 3, so this one is also a scaled copy. Okay, so I'm looking at my trapezoid here. I know that going from 9 to 3, I can divide by 3. Going from 15 to 5, I can also divide by 3. So far, so good. But if I do 10 divided by 3, I do not get 4. So this one is not a scaled copy. That 10 to 4 messes it up. Okay, to go from 2 to 6, I multiply by 3. To go from 5 to 15, I also multiply by 3. So since I multiply both the side and the base by 3 to get my new side and my new base, this is a scaled copy. Okay, so now we know how to figure out if they're scaled copies. And in this one right here, it says I can find the missing side length of scaled figures. So it is telling us that these are all scaled figures. Okay, so that gives us a clue that we can use. So to go from 7 to 1, I divide by 7. And if I divide this side length by 7, I'm also going to divide the base by 7. So 14 divided by 7 will give me 2. This is very similar to finding equivalent fractions. Remember, if you multiply the top by 2, you multiply the bottom by 2. If you divide the top number by 5, you divide the denominator by 5. It's very similar. Okay, so I can see from this one that it's a square because this side is 4 and this side is also 4. So if I know this side is 10, then this side has to be 10 because it tells me it's a scaled figure and I want it to stay in the shape of a square, so it has to be a side length of 10. To go from 15 to 5, I divide by 3. So if I divide one side by 3, I have to divide this side by 3 to get my question mark. So 12 divided by 3 is 4. So that side length will be 4. And then last, we have some trapezoids. To go from 9 to 3, I divide by 3. To go from 15 to 5, I divide by 3. Well, I don't have a number here to divide by 3, so I'm going to think opposite. The opposite of division is multiplication, so to go backwards, I'm going to do 4 times 3, and 4 times 3 is 12. And if I want to double check that answer, now I can say, yeah, 12 divided by 3 is 4. So I can double check that. Okay, so we have another definition, another vocab word. This one is corresponding. Corresponding parts are parts that are in the same relative position but in different figures. This can be sides, angles, points, etc. So there are several here. I'm just going to highlight a few for you so you can kind of see what I'm talking about here. Okay, so for example, if I were to put a dot on this point right here, the corresponding point on my scaled figure would be right here. So see how those are corresponding? If I were to put a line right here for this side and a line right here for this side, those two sides are corresponding. This angle and this angle are corresponding angles. This angle and this angle are corresponding angles. This side and this side are corresponding sides. So it's basically, if you were to make this bigger, the corresponding sides are in the same relative position. Okay, so those are just a few examples. You could highlight any of the sides, any of the angles. There's several more points. This point right here corresponds with this point right here. So lots of examples there. So if we were to look at these shapes right here, let me get my highlighters. Okay, so if you notice, these shapes are not going the same way. So they've been turned. So to go from this shape right here, it's been turned. Okay, so I have the slant right here. So the corresponding side over here is still the slant. It's just been turned. This is what I'm going to call my base. And this is also my base. So those are corresponding sides. This top right here and this top over here are corresponding sides. And then this side and this side are corresponding sides. Okay, so those are corresponding sides. If I want to talk about angles, this angle and this angle correspond. You see how they both meet where that orange and green line are? Orange and green line. This angle, I'm going to do 2 lines, corresponds to this angle. 2 lines. I'm going to give this one 3. 1, 2, 3. And the corresponding angle is Q. 1, 2, 3. And then this angle right here, I'm just going to circle. There's a lot of lines there, so I'm just going to circle it. So those are corresponding. So if I were to turn this, all of these colors and angles and lines would match up. Okay, they're corresponding. So let's look at these triangles. So this is my shortest side right here, and it corresponds to this short side right here. This is my base, and it corresponds to this side right here. Those are my 2 longest sides. And then this side and this side correspond. So once again, if I were to take this triangle and turn it, the colors would match up with the side lengths. Okay, so those are corresponding sides. Corresponding angles. So here's my green and purple. Green and purple, those 2 angles correspond. And then I have this obtuse angle. So I'm going to put 2 lines there, and it corresponds to my obtuse angle over here. And then I have this acute angle, has a red and a green highlight, 1, 2, 3, and that corresponds right here to the red and green highlight, 1, 2, 3. Okay, corresponding sides and angles. Scale this polygon so the side that corresponds to 15 units in the original is 5 units in the scaled copy. Okay. So 15 units in the original is now going to turn into 5 units in the scaled copy. So we need to find that side that's 15 in the original. And now in my scaled copy, that 15 is going to be forced into 5. Well, to go from 15 to 5, I divide by 3. So to keep it scaled, remember, I have to divide every single side by 3. So let's do that first. If I divide 15 divided by 3, I get 5. 18 divided by 3, I get 6. 36 divided by 3, I get 12. 30 divided by 3 is 10. 21 divided by 3 is 7. And 12 divided by 3 is 4. Okay, so what these answers are to these equations are going to be the lengths of my new sides. Okay, so if I am dividing by 3, my shape is going to get smaller. So this first side is going to be 5, and I'm going to highlight it so I don't lose track of where I'm at. Okay, let's just highlight a couple sides so we know where we're at. Okay, so this 5, this line right here, corresponds to this 5. And then I'm going to go up and do this green line, which is now going to be 6, so a little bit longer than the 5. And I'm going to highlight that in green so we see that they correspond. Now I'm going to go over, and my new side length in my scaled drawing is going to be 12. And it doesn't have to be perfect, that's why we label it, because it's not going to be drawn perfectly, but as long as you label it, we know exactly what our side lengths are. Now I need to go down, and it's going to be 10 in my scaled copy. So I'm going to label this 10. And then my new side down here is 7, so I'm going to go across 7. And then this side right here is going to be 4. And I'm going to label it 4. Okay, so going from my original to my scaled drawing, it got smaller. And that makes sense because I'm dividing by 3. So it should look exactly like this, but smaller. So we're going to do a little practice with corresponding parts here. And I'm going to highlight these. So we can see a little bit better what we're doing here. So I have an original, I have a copy 1, and a copy 2. Which, first of all, if I was looking at these 3 and this was my original, this to me, without doing any measurements, looks like it would be a scaled copy. Okay, it's smaller, but it still looks like it has the same proportions. This one looks like it's been stretched, so this one would not be a scaled copy. Okay, it's been stretched out. Okay, so we're going to fill in our chart here. So in the original, I'm looking at point P, which is right here, and it wants to know what the corresponding angles or points are for copy 1 and copy 2. Okay, so for copy 1, it's going to be point F. And then for copy 2, it's going to be point Z. The next one in the original, line segment LM. So So that's from here to here, LM. And this is important. Order matters. And I want you to write that down, put a big box around it. The order of the letters matters. Okay? So if I'm starting in the middle, LM, and I'm going down, I'm going to start in the middle at B and go down to C. So it's going to be segment BC. I'm going to put a line above it. That means segment. Okay? It would not be correct to write CB because that's starting from the bottom and going up. But I'm starting at L. I'm starting at the top and going down. So I have to start in the middle at B and go down to C. And on this one I would start at V and go down to W. So it's going to be VW. Okay, now I'm starting with copy 1 and it says segment EF. So I'm going to find EF. So I'm starting in the middle and I'm going down to the right. Okay, so if I start in the middle here and go down to the right, it's OP. OP, not PO, OP. Okay, and then going back to my original, or my copy 1 that's given to me. Remember, we're doing EF, starting in the middle and going down to the right, and copy 2 would be YZ. Line segment YZ. Okay, now it gives us point W and copy 2. So point W, I'm just going to put a little dot there, is right here. So the corresponding point in copy 1 would be point C. Point C. And the corresponding point in the original would be point M. Point M. Now we're looking at angles. I wish I had more colors. Let's see. Angle KLM in the original. So I'm starting right here. KLM. And order matters, so I start up there again. ABC. An angle you can write like this. Angle ABC. KLM, ABC, and UVW. Start at the top, UVW. And it has to be in that order. UVW. And then our last angle, we are starting in copy 2 at angle XYZ. So X starts in this bottom left corner and it goes up and down. XYZ. So in copy 1, that's going to start at D, go to E, and then F. So angle D, E, F. And over here, I start in the bottom left again, N, O, P. Angle N, O, P. Okay, in just a second, you are going to get an activity page. And yours will look like this, but I drew some different shapes because I didn't want to give you the answers, but I wanted to show you what you're going to be doing on your activity page. So, at the top, you will get a shape. And yours will not look like this, it will look different than this. So this is your original, and it says it wants you to draw a scale copy with a scale factor of 1/2. So what that means is I'm going to multiply every side by 1/2 to get my new shape. So before I can do that, I need to label my sides. So 1, 2, 1, 2, 1, 2, 3, 4. Okay, so I'm going to start with that. And if I am making a new shape with a scale of 1/2, well, like we saw in the warm-up, multiplying by 1/2 is the same as dividing by 2. So if I divide this side by 2, I get 1. If I divide this side by 2, I get 1. 4 divided by 2 is 2. And then I just connect this. Okay, so we multiplied all of our sides, multiplied all of our sides by 1/2. which is the same thing as dividing our sides by 2. Now it wants you to draw it with a scale factor of 1. Well, if I multiply these sides by 1, I get the same exact shape, because 4 times 1 is still 4, 2 times 1 is still 2, and 2 times 1 is still 2. So a scale factor of 1 does not change this shape. It actually gives you the exact same shape. And make sure that you label your sides so I can see exactly what you're doing, because these grids are a lot larger than the grids on your test. And so I want to make sure that if you accidentally miscount how many grids there are, at least you labeled it correctly. Okay, so let's look at this one. So if this is my original, I'm going to put an O for original. And it wants me to draw a scale copy with a factor of 2. That means I am multiplying every side by 2. So my length up here is 2. My length on this side is 2. Right here would be 1. Right here would also be 1. Right here is 1. 1, 2, 3. So this is 3. Okay, so now I have something to start with. So 2 times 2 is 4. So this top side is now going to be 4. 1, 2, 3, 4. 2 times 2 is 4 again. So this side right here is going to be 4. 1, 2, 3, 4. 1 times 2 is 2. So 2. Going down, I have 1. 1 times 2 is 2. Going over, I have 1. 1 times 2 is 2. And then this last side is 3. 3 times 2 is 6. 1, 2, 3, 4, 5, 6. Okay, so your scale factor is just telling you what you're multiplying each side by to get your new shape. And you'll know it's right if all of your sides line up and you can, close off your figure. So make sure that you start with labeling your original with the side lengths, so then you know what you're starting with to multiply by. Okay, good luck.